In this video, we're going to look at oxidation and reduction. We're going to figure out which reactant is oxidized, which one is reduced, and which one is the oxidizing agent or the reducing agent. So we figured out what redox and non-redox reactions are. Now we figure out oxidation and reduction. Okay, so this is happening within a redox reaction. All right, so now we're saying like, woo, we've got a redox reaction. Now I need to figure out even more vocabulary, yay, and figure out which reactant is oxidized and which reactant is reduced. I'm gonna be real with you, these two terms get flip-flopped a lot. Lots of students get confused, so let's make sure you're super solid on this. All right, first point to make sure is everyone has to be really confident in assigning their oxidation numbers. All right, so if you need extra practice with oxidation numbers, do extra practice, but you have to be good at assigning your oxidation numbers to determine this stuff, okay? In a redox reaction, one reactant is oxidized, the other is reduced. Okay? Hey, what the heck does that mean? So if I looked at a nice little number line, okay, here's my nice little sliding scale, right? This would be my sliding scale of oxidation numbers. All right, and it goes from -7 up to +7 for oxidation numbers. Okay, think of these as your oxidation numbers. If your number of your reactant goes up, the oxidation number is going up. Your number goes from a smaller number up to a bigger number. It's getting oxidized. Okay, if it goes, I'm just going to cover this up, all right? If your number is going this way, you're getting bigger on your oxidation scale, so you're oxidizing. If, however, the number is going down, if you start at a higher number and it's going down, your number is reducing. Your oxidation number is going down. It reduces. Okay, whatever that thing is that the number went down, reduced. There are two monikers that are relatively common for this, okay, for how to remember which is oxidizing, which is reducing. And it's either oil rig or Leo the lion says grr. Whatever, okay? However it helps you think about what is going on this sliding scale, you do you, okay? What this says is OIL for oil rig. Oxidation is losing electrons, oil, and reduction is gaining electrons. And that hopefully makes sense, right? If we think about what an electron is negative, right? So if I'm gaining electrons, if whatever compound I am, I'm gaining electrons, my charge is getting more negative, right? So if I was up here and I get more and more electrons, my number is going down, 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 down. Okay, so if my number is going down, if I am reducing, that means I am gaining electrons. I am getting more negative. If, on the other hand, if my number is going up, right, how would my charge of a compound go up? The only way I can get my charge to go up, it's not like I'm adding protons to stuff, right? I'm not saying like, okay, here are some more positive things, go be more positive. No, the only way to get a higher positive charge would be to get rid of those negative things, right? So if you are oxidizing, that means you are losing electrons, okay? You are getting rid of negative things. That's how your number is getting higher and higher. So that's what these two little monikers are. Any way that helps you remember, okay, oil rig, oxidation is losing, reduction is gaining electrons, or Leo the lion says grr. These, you know, if you go to the Googles and you're looking up oxidation and reduction, I'm sure these two will come up. So if you lose electrons, it's oxidation for Leo. Lose electrons is oxidation. Gain electrons is reducing for your Leo the lion says grr. All right. How about some actual problems? So we have iron 2 oxide plus carbon monoxide react to make iron and carbon dioxide. Okay, so I need to assign oxidation numbers. So oxygen 2 minus, iron's a 2 plus, 2 minus here, so carbon's a 2 plus, iron's in its elemental form, it's a 0. 2 minus from the oxygen, and there's 2 of them, so my carbon has to have a 4 plus to balance it out. Okay, so I've assigned oxidation numbers. Now, okay, I need to look and see what's going on. My iron went from a +2 to a 0. Okay. So I went from +2 down to 0. My oxidation number for iron went down. It reduced. So FeO is reduced. Can't spell. Okay, so iron 2 oxide is reduced. Why? Because iron went from a 2 plus charge to a 0 charge. This went down. All right, versus carbon went from a 2 plus up to a 4 plus. Right, I went from 2 plus up to 4 plus. So I'm moving up this scale. So let's move this. Okay. That means carbon monoxide is oxidized. Why? Because carbon went from a 2 plus charge up to a 4 plus charge, which means it went up. All right, so you're just trying to figure out which reactant was reduced, which reactant was oxidized. Once you figure this out, you say, okay, carbon monoxide, oxidized. Iron 2 oxide, reduced. And you would label it like this, okay? Or it might be a multiple choice question, you know, which reactant was oxidized. So you have to figure it out and you'll, you know, select B, carbon monoxide. Which reactant was reduced? C, iron 2 oxide, whatever, okay? So you have to be able to identify which is reduced, which is oxidized. The last piece of this, okay, is we introduce the word agent. Why? Why do we do this to you, okay? We can't just say something is oxidized or something is reduced. Now we have something called the oxidizing agent and the reducing agent. Okay, this is by far the biggest flippity flop that's made with this terminology. So all it means, right, we'll look at our example that I threw on the floor here, okay? All it means is that once you determine which is reduced and which is oxidized, then it's kind of like a secret agent. Then it's like they were working for the other guy, right? So this guy was oxidized, so he is the reducing agent. He forced the other thing to get reduced. Why do we do this? It's so counterintuitive, okay? Iron 2 oxide got reduced, so that means he forced the other guy to get oxidized. So he's the oxidizing agent. All right, so because this guy is oxidized, he's going to be the reducing agent. Because this guy is reduced, he's the oxidizing agent. Okay, you can tell I love this, right? So honestly, my tip to you is to just first figure out what's reduced and what's oxidized. Okay, that's key. All right, once you figure out which is reduced and which is oxidized, then you can just flip the terminology to figure out which one is the reducing agent or the oxidizing agent. It means the same thing, right? You are figuring out what's going on with these electrons, which one gained electrons, which one lost electrons. It's just a different way to talk about the same thing. Okay, so don't let it scare you. And even if the question itself doesn't say figure out which one is oxidized, it just says find the oxidizing agent, it's still easier. You're less likely to get the question wrong if you just take the time to say this one's oxidized, this one's reduced. Okay, do carbon monoxide plus water react to make carbon dioxide and hydrogen gas. Okay, oxygen 2 minus, carbon 2 plus. Oxygen 2 minus, hydrogen 1 plus. They do balance out, right? There's 2 pluses here, 2 minuses here, so it evens out to 0. All right, 2 minus 4 plus, 0 because it's elemental, okay? All right, so now if we're looking, carbon went from a 2 plus to a 4 plus. Its number went up, okay? Here we go, all right? If you go up your oxidizing number, that means you are oxidized. All right, and hydrogen started at a 1 plus. It went to 0. It went from 1 down to 0. It goes down. That means it gets reduced. Okay, so I would write out that the compound that had carbon in it, carbon monoxide, oxidized. The compound that had hydrogen in it, reduced. Which then means, since carbon monoxide was oxidized, it forced the other guy to get reduced. So he's the reducing agent. Since water got reduced, he forces carbon monoxide to get oxidized. So he is the oxidizing agent. Ugh, we hate it. It's death. Hopefully it's not too terrible with the terminology. That's it. Long video. Ugh. All right. Good luck.